So what we're going to be learning today is how to add and subtract rational expressions with factor denominators that are not alike. Might want to get a piece of paper, pencil out, journal. I know it's exciting stuff here. All right, exciting stuff. All right, so you want to be able to know how to show your work so you can receive full credit. That's Chewbacca showing his exuberance and enthusiasm for this lesson. All right, so let's take a look at these denominators here. Exuberance, yes, exuberance. 5m minus 8. We've got an m minus 4. Ooh, we've got an m minus 4 on this one, so they share a common factor. And then last but not least, we have the binomial, also known as 3m plus 7. Now, quick little review when you're adding fractions. What you should know is that you have to have the same denominator in order to add a fraction. So, for example, if I had 1/2, all right, and I had 5 halves, I could add these together because they have the same denominator, and that would give us 6/2, which reduces to 3. All right, but if I had two different denominators, like 1/2, and I was trying to add 1/3, well, I can't add these because these don't have the same denominator. Well, what does this denominator have that this doesn't? It has a 3. So what does it need? It needs a factor of 2. All right, and this one, it needs a factor of 3. So what would be the least common multiple? The least common multiple, also known as LCM, of a 2 and a 3, the least common multiple is 6. And if you forgot, like, what the heck are multiples? Multiples are like 2, 4, 6, 8, and keeps going on. And then a multiple of 3 or 3, 6, 9, 12, 15, and it just keeps going. But the least common multiple is the number 6. That's the one that they have, that's the smallest number that they have in common. Okay? A common multiple is just a number that they also just share in common. So another, for example, common multiple between a 2 and a 3, another common multiple is the number 12. So that's a common multiple, but that's not the least common multiple. So what we're trying to find is what's called the LCM, the least common multiple. So quickly, let's just do this one. We got 3 times 1, which is 3/6. And 2 times 1 is 2/6. And so we would add them together, and we would get 5/6, and that would be our answer for what's 1/2 plus 1/3. Well, we're going to use a very similar concept when we're working with these, except we're going to be dealing with factors that are binomials instead of just factors that are just constants. So, right now, the first thing I want you to do is we are going to write down what the LCM is of this problem. Now, the least common multiple of these two denominators is going to be 5m minus 8 times m minus 4 times 3m plus 7. When it says keep the denominator in your answer in its factored form, this is what it's referring to. This is what our denominator is going to be like in its factored form. That's what I'm going to put in right here. I'm going to go ahead and just pre-write it in. Right here, the denominator I'm going to write is 5m minus 8, m minus 4, and 3m plus 7. So I'm going to go ahead and just pre-write that in, knowing, and it really doesn't matter which order that you put them in, because if I said what is A times B times C, that's the same as B times A times C, or CBA. It really doesn't matter how you put numbers together when you're multiplying. It doesn't matter which order. So don't worry about the order that you put them in. Okay. So please write that down, and then we're going to go ahead and go down here, and we're going to write it out. I'm going to write it all nice and neat. I'm going to pause the video and write it nice and neat for us. All right. So I have everything typed out nice and neat for us to work on. One thing we're looking at this denominator. It has a 5m minus 8 and an m minus 4, but it needs the factor 3m plus 7. So what I have to do on this side is I have to multiply it by the fraction known as 3m plus 7 over 3m plus 7. And that will now give us our least common multiple. Probably heard something that sounded like a clap in the background. That was just my wife. She's painting and she was shaking up her paint.
It was a clap.
It was a clap. She said,
Yay!
"Yay! Good job." All right, so over here, let's look at this denominator. So this has a 3m plus 7 and m minus 4, but it's missing the binomial 5m minus 8. So what I have to do over here is I have to put 5m minus 8 over 5m minus 8. Now, this will give us our common denominator. At this point, all you have to do is take this 7m, use the distributive property, multiply it to both of those numbers right there. I'll go ahead and put these right over here. So we have our final denominator. Our final denominator is 5m minus 8 times m minus 4 times 3m plus 7. We're going to do 7m times 3m, which is 21m squared. And we have 7m times 7, which is a total of 49m. I'll switch colors here. I'm going to take 10, multiply it to the 5m, and 10, distribute it to the negative 8. And we're going to put plus 50m, because 10 times 5m is 50m. 10 times negative 8, negative 80. And once you've done that, you just got to look for some like terms. It looks like the only like terms we have are 49m and 50m. It gets us a total of 99m. So, what am I going to type in for my final answer? My final answer is going to be this really long trinomial, 21m squared plus 49m, not 49m, change that, 99m, all right, minus 80. I'm going to type that nice and neat into the Khan Academy. So head over here, I'm going to make a little fraction, 21m squared plus 99m minus 80. And like I said, it really doesn't matter which order. I'm just going to go ahead and just type in 5m minus 8. That's one of ours right here. The other one was m minus 4 right here. And the last one, we're going to do 3m plus 7. 3m plus 7. Let's go back, make sure I typed everything in. 21m squared plus 99m minus 80. Minus 80, looks like I typed everything in correctly, and then I hit check. Alright. Alright, so what I'm going to do is we are going to find the least common multiple, and we are going to give our answer in its factored form. I'm going to type these out nice and neat right here for us to see, so I'm going to go ahead and try to do that. I'm going to pause the video here in just a second. Alright, so what we're going to do is we're going to factor these completely, and then we are going to create what's called the least common multiple between all of the factors. So, a number it's divisible into a 5 and a 35 and a 50 is the number 5. So I'm just going to put 5. And the greatest number of m's that's common to all of these is m to the power of 5. So I'm going to factor out m to the power of 5. We're going to see what we have left. If I fact, basically all we're doing is we're dividing all of these by a 5, m to the power of 5 on each one of those. So that's all I'm going to do. Alright, so these 5's will cancel out because they're common factors. Everything's going to cancel out here except for an m squared. 35 divided by 5 is 7, so it's 7. And 6 minus 5 is 1, so all of them cancel out except for 1m. And then at the end, we have 50 divided by 5, which is 10, and m to the power of 5 divided by m to the power of 5. Those completely cancel out. And then we have a nice, neat binomial, and then all you have to do is think of two numbers that add up to 7, but those exact same two numbers multiply together to equal 10. If you're wondering what in the world we're doing, we're kind of reviewing factoring right here. Like I said, once again, we're looking for two numbers that add up together to equal 7, but those exact same two numbers multiply together to equal 10. Well, what are the only factors of 10? 10 times 1 and 5 times 2, and 5 and 2 are the numbers that work, and those are the numbers we're going to use. M plus 5 and m plus 2, and this is everything broken down nice and neat into its factored form. So this is this expression completely factored. Now we're going to head over here, and we are going to factor this guy as well. First thing that I'm going to do is I'm going to factor out this this negative. I'm just going to factor him out. Makes it a little bit easier. And I'm also going to factor out a 20, because 20 is divisible into 20, into 80, and into 100. So I'm going to factor that out, negative 20. And then the greatest number of m's that's common to all of these is to the power of 3. So I'm going to factor out m to the power of 3. And we'll see what we have left. So once again, all I'm going to do is divide everything by a negative 20 m cubed. Negative 20 m cubed, negative 20 m cubed. And that leaves us with m squared, because negative 20 divided by negative 20 is 1, and m to the power of 5 divided by m cubed is m squared. Now if you're wondering how I'm doing this, basically m to the power of 5 is m being multiplied to itself over and over and over again 5 times. And m cubed is being multiplied over and over and over 3 times. And so what happens is any number divided by itself is equal to 1 except for 0, because you can't divide by 0, but you're left with m squared. So that's how I got the m squared. Now negative divided by negative is a positive, so right there I'm going to put a positive. And then we have 80 divided by 20, which is 4. So 4m, because 4 minus 3 is 1. That's called the quotient property. And then we have 100 divided by negative 20, which makes that a negative 5. All right, so what we're going to do now is we are going to factor this right here. So we have negative 20 m cubed. And then what now we're doing is we're looking for two numbers that add together to equal a 4, but those same two numbers multiplied together equal a negative 5. And the only factors of 5 are 5 and 1, so I know I'm going to have a 5 and a 1 and a 5 and a 1, but I have to make the 1 negative, and the 5 stays positive. So I'm going to put m plus 5 and m minus 1. So now I have everything completely factored into its factored form. So now that I have everything in its factored form, now we got to figure out what do we have that's the same and what do we have that's different, and that's going to help us build our least common multiple. So I'm going to write down what I think our least common multiple is going to be. Well, it looks like we do have something that is exactly the same, so that's a common factor, so that's going to be a part of our least common multiple. That's m plus 5. And that's the only common factor. So now we got to figure out what's the least common multiple between a 5 and a 20. Well, the least common multiple is actually 20. So I'm going to put a 20. But I also have to put a negative. So I got to make that a negative, because we got to have the negative as part of that denominator. So we have a negative 20. That's the least common multiple between the coefficients. Now we got to figure out what's the least number of m's that we can have. Well, it says m cubed and m to the power of 5, but we always have to go with the greatest, because we have to have this common to both. So this is the smallest number that's going to be common to both. denominators if we had to add, if these were the denominators of a fraction. The next factor I'm going to put is m plus 5, because that's common to both. And then I'm going to add an m plus 2, and then finally I'm going to add an m minus 1. Alright, so let's think about, probably the thing that's probably the most confusing is like, how do we find the least common multiple between a 5 m to the power 5 and negative 20 m cubed. So I'm just going to break this down. When we have a 5, we have times m times 2, 3, 4, 5. Okay? And then over here, we have a negative 1 times, and the factors of 20 are 2 times 2 times 5, and then the factors of m cubed are m times m times m. So what we have to do is we have to find what's called the least common multiple between two of these. So what we have to do is the least common multiple has to have 1, 2, 3, 4, 5. It's got to have at least m to the power of 5. So I know I have to have m to the power of 5. If I had 1 over m to the power of 5 plus 1 over m cubed, my least common multiple would be m to the power of 5. And what I would have to do is I'd have to add an m squared over an m squared so that they could have the same denominator. And then this expression would be m squared over m to the power of 5. Okay? Actually, m squared plus 1. There we go. So I'm going to go and erase this right here. Now, the next thing we have to look at, knowing that we have to have m to the power of 5 in our least common multiple. Now let's look at our coefficients. Coefficients. We got to have a 5 in the coefficient. So since it shares it in both, we just have to have 1, 5. But we also have to have a couple of 2's. And we also have to have a negative 1. And when you multiply all these together, you're left with negative 20 m to the power of 5. And that's why that has to be this term right up here up front. But the answer that I'm going to type in right here, the least common multiple between this expression and this expression is this right here. So you have to really to know how to factor to get the least common multiple. So I'm going to carefully type that in. So we have negative 20 m power of 5 right here, negative 20 m to the power of 5. And then we have an m plus, not minus, plus 5. We have an m plus 2 and an m minus 1. An m plus 2 and an m minus 1. And that is going to be our least common multiple. Alright, now I'm going to show you a step-by-step solution and see how they break it down. Alright, so they broke it down right here into 5 m squared, m to the m cubed, m squared. Let's see, they broke it down the same way, just a little bit harder to see in words than it is just watching the video. So we're going to do a couple more problems and see if this helps. Okay. All right, I'm going to go ahead and pause the video right now. And I'm going to type our denominators in nice and neat. Alright, so here I've typed things in. We have an 8y plus 9 right here in the denominator. We have a 2y minus 3 in this denominator. And you'll see that this other denominator shares that factor, so that's already common to both, so that's good. It makes it a lot easier. And then we have an 8y minus 7 here. And so what we're doing is we need to find what's called the least common multiple. Like what's going to be the denominator for our final answer. So I'm going to make that denominator. And I'm just going to build it right now. I know we're going to have an 8y plus 9. That's got to be there. We also have to have a 2y minus 3. And last but not least, we have to have an 8y minus 7. So we have to have that as well. All of this together is what's called the least common multiple. So I'm going to go ahead and just put that right over here. I'm going to rewrite it. 8y plus 9. And I'm just going to keep it all the same color. Save some time. Alright, so there's our least common multiple. Now we just have to look at this denominator and ask ourselves, what does this need that it does not have? It has the 8y plus 9, it has the 2y minus 3, but it needs the 8y minus 7. So what I have to do is I have to create a little fraction. And basically, all I'm doing is I'm making it have the same denominator. Like 8y minus 7 divided by 8y minus 7 is equal to 1, unless y is equal to y can't equal 0. Well, actually, it can in this particular case. All right, it can't equal. It can't make the denominator can't equal 7/8. But other than that, it will divide and make itself equal to 1. So I'm not changing the value of the number. I'm just changing the way it looks. So once we have that, then we're going to go over here and we're going to look and see what this needs. Looks like this has the 8y minus 7 and the 2y minus 3, but it needs the 8y plus 9. So I'm going to make another fraction. And in the numerator, we put 8y plus 9 and 8y plus 9. Now, all I have to do now is simply take this number right here, this 3y, and distribute it to both terms. So when I do that, I get 3y times 8y, which is a total of 24y squared. I have 3y times a negative 7, which is a negative 21y. Once I'm done there, do you see this negative right here? It's very important. I'm not just going to take this y squared, but I'm actually going to make it I'm going to multiply it by negative y squared to both terms. So I'm actually just going to go ahead and just take that negative and multiply it into the expression, save myself a little bit of time. So if I have a negative y squared times 8y, that gets me negative 8y cubed. If I have a negative y squared times a 9, that gives me a negative 9y squared. So at this point, all we have to do is search for like terms. So we don't have any other cubed, so I'm just going to put minus 8y cubed right there. Looks like we have 24y squared minus 9y squared, so that's going to give us a total of 15y squared. And then we have minus 21y right there at the end. Okay? So all you have to do is you look for like terms and make sure that you combine those like terms. So this 24y squared minus this 9y squared gives you a total of 15y squared. And so this is what I'm going to carefully type in to the Khan Academy. Make sure I have everything nice and neat and have those factors. Remember, it says keep the denominator in its factored form. If you're doing the packet, make sure you keep it in factored form. Okay? Alright, here we go. Make a fraction. I'm going to go ahead and build my denominator since it's right there. 8y plus 9, 2y minus 3. And the last one was 8y minus 7. Just remember, it doesn't really matter which order you put these in. I'm going to start with negative 8y to the power of 3. And I believe it was plus 15y squared. And then I believe it was minus 21y. But before I hit check, I'm just going to make sure. Negative 8y cubed plus 15y squared minus 21y. I think so. Got that. Got that. Looks good. Alright, here we go. Alright, and our last problem. Okay, our last problem says keep the denominator in its factored form. So I'm going to pause the video. Once again, make my denominators nice and neat so you guys can see them clearly. Oops, 1 second. Alright, so I have everything typed out nice and neat. I'm going to highlight our denominators, our factors, our binomials. We have a 2y plus a 1 right here. We have a y minus 7 here and here, so we have a common factor in both denominators. Alright, by the way, this is supposed to be a y right there. I'm not sure why it didn't show up. And then we have a 2y minus 3 right here. So the very first thing we have to do is we have to find what's called the least common multiple. And the least common multiple is, since they already have a y minus 7 in common, we're only going to use that once, but we have to have a 2y plus 7. We have to have a y, or 2y plus 1. We have to have a y minus 7. And then we have to have a 2y minus 3. So we have to have all of those together represent what's called the least common multiple. So that's going to be our denominator. So now we look over here and ask ourselves, what do we need that we don't have? We have the blue and the red, but we need the green. So we are going to multiply the numerator by 2y minus 3 over 2y minus 3. Over here we have the green and the red, but we don't have the blue, so we're going to multiply. Change colors real quick. We're going to multiply everything over here by 2y plus 1 and 2y plus 1. Alright, so now we have the least common multiple as our denominator, which is all of those multiplied together. But the cool thing is we get to leave it in factored form. We don't have to multiply everything out. Alright. So there's our answer in factored form right there. It does not matter which order you put them in. This is the same as this, even if it's in a different order. Okay. Alright, let's multiply. We've got a y. We're taking that y, we're multiplying it times a negative 3. Taking the y, multiplying it to the 2y. So y times 2y is 2y squared. And y times negative 3 is negative 3y. Okay? Then we have 2y squared, multiplying that to a 2y. Then 2y squared, multiplying it to a 1. 2y squared times 2y is a total of positive 4y cubed, and 2y squared times 2 is 2y squared. So when you have a plus, it makes it a lot easier because all you got to do is just multiply this, whatever that is, just keep it positive, multiply it to both. And then now we just got to search for like terms. It looks like the only terms that are going to be alike are this 2y squared and this 2y squared. Okay? So that becomes 4y squared. So here we go. Here's our final answer. We're going to start with 4y cubed right here. Then we're going to add 4y squared. And then we're going to put minus 3y. And that's what's going to go into our numerator. So this is going to be our final answer right here. I boxed it in. It's going to be our final answer to this problem, and we're going to type it into the Khan Academy. Alright, first thing I'm going to do is make a little fraction. Start with my denominator because it's the easiest. I got a 2y plus 1. I have a y minus 7. And last but not least, I have a 2y minus 3. Alright, so there's my factored form right there. Just keep the denominator in your answer in its factored form. So I'm keeping it in its factored form. Now I'm going to carefully look at what I wrote down, which is 4y cubed plus 4y squared. Let's start there. 4y cubed plus 4y squared, and last but not least, minus 3y. Minus 3y. All right. Looks like I've typed everything in carefully and accurately. Yay! We got 100. Hope that happens for you as well. You'll have a wonderful day.